This video concerns translating between radical expressions and powers with fractional exponents. So we'll just start right into the examples so that you can tell what I'm talking about. So suppose you have this particular question. The fifth root of 32 raised to the seventh power. Now, this is obviously a radical expression, but every radical expression written like this can be rewritten as a power utilizing a fraction as an exponent. Now, this 32 raised to the seventh, will serve as the numerator of the fractional exponent, and the index 5 will serve as the denominator of the fractional exponent. So we have 32 raised to the 7/5. Now always have the powers table accessible so that you can look up numbers like 32, and if you look it up carefully you'll find that 32 is 2 raised to the 5th. Making a replacement for 32, 2 raised to the 5th, further raised to the 7/5 power, which becomes 2, and using a property of exponent to an exponent, you would then multiply 5 times 7/5, which becomes, when those 5's cancel, 2 to the 7th, and again you can look that up in the powers table, and that is 128. Final answer for that example. Question B looks pretty intimidating. Fourth root of 243 times eighth root of 729. Now, to try to play off the previous example where we had 32 raised to the 7th power, it would be a good idea to look for 243 in the powers table. And once you find it, you realize that 243 is the same thing as 3 to the 5th. And continuing your search among the powers, you'd realize that 729 is 3 to the 6th. Now, translating each of these radicals using the method discussed in the first example would become the first radical. 3 would be raised to the 5/4 power, and in the second radical, 3 would be raised to the 6/8 power. Now, using the property of exponents, that one power times another, you may add the exponents. You would be adding 5/4 plus 6/8. And you can use your calculator to do that. And in fact, you can use your calculator to verify this entire problem. 5/4 plus 6/8 is just 2. So this final, very intimidating looking problem becomes just 3 squared, or 9. Third example. This is a problem involving a fraction, 12th root of q to the 11th divided by 6th root of q raised to the 4th. This will become a much easier problem if we translate each of these radicals to a power with a fractional exponent. The numerator, using the same ideas from the first example, would become q raised to the 11/12. The denominator would become q raised to the 4/6. Now, a further property from exponents, you would take this top exponent, 11/12, and subtract the exponent of the denominator, 4/6. So that is 11/12 minus 4/6. And once again, you can use the calculator, or you can get a common denominator for these two. That becomes 11/12 minus 8/12. And 11/12 minus 8/12 is 3/12, which further simplifies to 1/4. So this is q raised to the 1/4. Now, the specific directions state to write the final answer as a radical. Now we're going to use the very first property illustrated in example A and work it backwards. So this is going to become radical q, 4th root q to the first, but most people would just write that as 4th root of q.